All right, eighth graders. So today we started out with looking at our homework here. So let's go ahead and get to this. I did have a thing of this already finished, but I couldn't find it. So, anyways, the first thing that we're supposed to do is find our low pressure zone. So 989, that's our lowest value. So that's why that's our low pressure zone. I see our high pressure zone over here. It's 1,028, 1,028. I don't see any numbers higher than this, so I'm going to go ahead and label this as our high pressure zone. Now from here, we're going to go ahead and start at 992 millibars, and we're going to connect all of the points of 992 millibars and make these isobar maps. So I know I can connect these two. I can connect these two and these two. Okay, so there's our first isobar line. Next, we go up in 4 millibar increments. Why do we go up in 4 millibar increments? How do I know to do this? It says find the lowest pressure on the isobar map. Done. Construct a 992 millibar iso line around the lowest pressure. Done. Complete the iso lines in increments of 4 millibars up to 1,028. That's how I know how to do that. And then we also did this. We labeled the center with a low and the high center with a H for high pressure. Draw the directions of the winds and how they'll flow. We'll talk about that at the end. What's going on here? Oh, okay. There we are. So let's get rid of this guy. Let's scroll down again. Okay. So now we're going to 996. I see my 996 here. Here. I see a 996 here. Right here. I see 996 here, so I'm going to connect these 2 points. I know that 996 exists in between 992 and 1000, so I know my line goes in between here. Connect those guys. Same thing up here. So anything within this 996 line needs to be less than. Anything outside of the 996 isobar line needs to be greater than. So 998 is greater than. So that's how I know it goes outside. 1,000 is greater than 996, so I know it goes outside. Next is 1,000 millibars. So I draw this. Do I go outside of the 998? Yes, because 998 is less than 1,000, so it goes within my isobar line. Through 1,000, I know 999 is less than 1,000, so it goes inside. Circle back around. My isobar line is going to go run inside here because 1,001 is greater than. Come back out here, go through 1,000. Come back up. I know 1,008 is greater than 1,000, so I'll exclude that. So there's our next isobar line. 1,004, I know 1,004 is greater than 1,003, so it goes on the inside. Here's 1,004 up here. 1,005 is greater than, so I'll exclude him. 1,003 is less than, so he goes inside. Come over here, 1,006 greater than, so I leave him outside. Run through 1,004. 1,005 is greater than, so he goes outside. And that was not a great way to finish that. That was almost a good one. Then we have 1,008. So I'll connect my 1,008. They're way out here. 1,008. Go down here. I see 1,008 here. 1,008. I know 1,008 goes through the middle here. It's greater than 1,005, but it's less than 1,010. Connect here. It's less than 1,012. Less than 1,012. It runs through 1,008. Runs through 1,008. Should have. 1,005 is less than. Okay. And then I finally get to my 1,012, which is right here. 1,012, 1,012, 1,012. Anything greater than goes on the outside of my isobar line. And then these 1,012s, they end right there. There's no way to reconnect it. I have to scooch this pane over here now. So now let's go ahead. Those lines are no longer connecting. So let's try to start around our high pressure zone. That's what I like to do. If you can't figure the other lines out, start around the high pressure and maybe work back from high pressure to low barometric pressure. So there's 1,028. 1,024. I know, so now it's the opposite. If I'm going from high air pressure to low, anything inside my lines has to be greater than that line that I'm drawing. So anything greater than 1,024 is going inside my line. So I know 1,020 is less than, so it goes outside my line. I'm going to go ahead and run through 1,024. 1,016 is less than, so it goes outside. 120 is less than. 124. 124. My next increment's 1,020. run through. 1016 is less than, so I exclude it. 1020, 1021 is greater than, so it goes inside. 1020 here. This will circle back around. And then finally I get to 1016, so I see this guy, 1016. Here's another 1016. Here's another. Anything greater than 1016 goes to the right, right? The greater numbers go to the inside, where the lesser numbers go to the outside. So 17 must then go on that side. And again, this guy's one who runs off the map because it doesn't really circle back around. There's no more values for us to see. And 1016, it then ends up connecting. Okay, so here's what your isobar map should look like. So let's look at some of these questions. It says, what part of the United States is the high pressure center located? So our high pressure center is located here in New York / Pennsylvania. You could say the Northeast, New England area, stuff like that. What part of the United States is low pressure located? Low pressure is located here in the Iowa, or you could have said the Midwest. Let's see here. On which side of the low pressure center would the winds be the strongest? Number 4, what's the evidence you have to support this question? This answer to this question. So if I look over here, I see that these isobar lines, if I look from this point on my 992 point to, let's say, 1012, I see a lot of isobar lines within a very short distance, right? If I cross from Iowa to Wisconsin over the Great Lake, it changes from 992 to 1012 millibars. So it's going from low pressure to high pressure this way. And so this is where our greatest winds will be. How come they're not over here? Well, let's look at the difference between, if I look at this point on 992 isobar, and then I place my second point all the way out here on this 1008, right? So here's the 1008 for that one, for the great wind side, but then here's the 1008 all the way over here. So what's going on here is there's the same pressure drop off here, except that pressure drop off, it lasts for hundreds and hundreds, maybe even 1,000 miles or more. So it takes a large area for that pressure to change as much as it changes right here over a very short distance, like 1/3 the distance or 1/4 the distance that pressure changes. So that's why we have great winds over here. The isobar lines are very close together. So that's how you would answer that one. Next question is number 5. In the next 2 days, what should New York people expect to happen in barometric pressure? Well, we know here across the U.S., our weather moves in this direction. Okay, so what's going to happen is this low pressure zone is actually going to make its way over here. So what's going to happen to the air pressure in the coming days? Well, the air pressure is going to go from a nice high 1028, and this low pressure zone is going to move this way, and so our barometric pressure would drop over the next coming days because this low air pressure is coming up on it. Gosh. So that's number 5. So circle the characteristics that the people would expect or should expect to see in the approaching low pressure system. So up here it said, draw the direction of the winds will flow around each of the 2 pressure centers. And so we did this on our last class. All right. So as air begins to rush from these areas of higher air pressure, they'll begin to sink to areas of low pressure. So air is trying to enter this low pressure system here. And so we'll actually get a swirling motion, just like if you take the plug off a drain, the water won't just bubble down into that empty drain. It will swirl around, make a vortex as it's going down, right? And air does the same thing. As it enters this low pressure, it actually bends like so. And there will be a cold weather front behind this, which is what we're learning about today. And then out front, what they'll first get is a warm air front. Okay, and so if this moves, and this does not fully rotate, it rotates a little bit, but what they're going to generally hit is this warm air front will hit New York first, followed up then by this cold air front a day or two later as it all moves through that northeast section of the United States. So then what can we expect for that day where the low pressure zone hits? Well, we can expect this warm air front to hit. And so what's associated with warm air fronts? Well, warm air, let's talk about warm air. We know it's warmer. So is it going to be dry or moist? It's probably going to be moist. If it's going to be warm, it has the energy to pick up moisture, and it's coming kind of from the south, and there's a lot of moisture in the south. So does warm air rise or sink? We know warm air rises. If we have rising air, are we going to have clouds? Yes, we will. We've learned this from the rain shadow effect. Okay, so there is that. Next, we're moving on. Moving on to this guy. Actually, I have this on here. So you'll need this actually for your homework, for the first question on your homework. And so we're supposed to be looking here at these maps. And these maps are looking at the same location, the same date and everything. So I see my air fronts here. Here's my warm air front. Here's my cold air front. Here's my warm air front. Here's my cold air front. Okay, so if I look at these guys, again, on that map that we just had, this would be the low pressure center normally, right? And this would be a low pressure center. All right, and so if I come over here, there's actually another one. Oh, look at that. Here's my low pressure center. We saw that warm, we saw that cold front. Over here, we did see another warm front, and we saw another cold front. Let's go back. So here's our low pressure centers right here. This is in Oregon, California, Nevada. This is over here in New York. If I back it up, boom, they're in that same place here. Okay, so we can see how those guys overlap just like that. We can also see our cloud coverage. Again, if I draw my warm front right here, it would end up right about here. If I draw this cold front, it comes down here like so. And so we see a lot of cloud cover behind our cold front and a lot of cloud cover right on top of our warm front. Same thing over here. I see this warm front right here, and then it's followed up here by a cold front. And then I see a cold front coming down from Canada right here. It's moving this way. So whichever side these triangles are on, that's pointing to the direction it's moving. Whichever side these bubbles are on, or those bumps are on, that's the side. So they're moving in this direction. This front's moving in this direction. This cold front is moving in this direction. This guy's moving in this direction. This guy's moving in this direction. Okay, and then we come down here and we see a very similar, like the map or the cloud coverage is the same thing down here for the precipitation right here. So we see our cold front right here. We see our warm front. Again, we see our cold front that comes all the way down here, and then we see our warm front up top. So we see this cold front right here, runs halfway through Florida, runs about halfway. Probably should scoot it up just a tad. We do see up here in our isotherm lines that these are the 20s, the 30s, so we know that it's cooler up here in the northern latitudes and it gets warmer down here in the southerly latitudes. The jet stream is just kind of showing that we push weather across from east to west across the United States. The jet stream is actually a wind pattern that takes place in the upper atmosphere, so we don't actually feel it down here on Earth. It's more of like a tropopause kind of effect, so it's about 15 kilometers off of sea level. Sorry, not sea floor. Okay, so let's talk about this. So what we did next, you may want to pause this video, come on over here, click on Weather Fronts YouTube, and you're going to watch this one with these little animations here. It sounds like they're talking through a tin can, not very good, but I mean, I like what they talk about, how they talk about it. It's 3 minutes and 12 seconds, so it's pretty short. So go ahead and do that. After that, I had you guys draw a diagram, or had my guys draw a diagram, and so we drew this on the board. So here's our cold front. Our cold front is represented on a map. So eagle eye view, this is if we're looking down upon it from like an airplane. And then, can you guys see me? Okay. It says blue with triangles pointed in the direction of the air movement. And then this is if we're a ground observer. So now we're standing on the ground and you're watching this cold air mass right here. Your cold air mass right here that's more dense. So we know that cold air, the particles are cold, so they come together, making them more dense. And then it causes the warm air to rise. So if it hits this, we know that this warm air mass is less dense, and so less dense material floats on dense material. So the warm air will rise here. As air rises anywhere, it will begin to form clouds. And then when these clouds form very quickly, there's a sharp rise. And this is where we get these thunderstorms. We get heavy rains that don't last for too terribly long. During the winter, we can get these snowstorms that happen when a warm front or a cold air front moves into a warm air front. Over here, we have our eagle-eyed view of this warm front. So this is the first front that comes in when a low-pressure system comes by. It's represented with lines, red lines with bumps pointed in the direction of the air movement. Again, if we're the ground observer, we see this warm air mass, and this one's actually moving into the cold air mass, so it's kind of catching up to the cold air mass here. It's less dense, and so it's actually, as it moves and it hits this cold air, it's kind of like a wall here. And so as it's less dense, it keeps moving, but as it moves up and over the cold air mass. So it's kind of like the cold air is like a mountain. So we talked about the rain shadow effect earlier. And I can see this warm air rising up and over. So I can be this little observer guy here, and I feel the cold air mass, but I can see the clouds forming up here in the atmosphere because it's actually warmer up here in the atmosphere as this warm air mass begins to move up and over the cold air mass. As we get this rising air again, we get these clouds that form, and they're long and flat. So today's Wednesday, we had a lot of drizzling rain going on for the most part of the day, and these clouds that seem to be never ending. So we had a warm air mass creep up and over a cold air mass. So anyways, that's the difference between those warm fronts and cold fronts. So go ahead and write that in your notebook. You might want to go back and open that up. Finally, I had everybody read pages 470 and 472 out of the book, so I'll go ahead and get that scanned onto here and begin to work on the weather fronts packet. And this weather fronts packet looks like this. So number 1 says examine the fronts map, cloud cover map, and precipitation map. That is this guy. So these 6 maps together here. It says examine the fronts, the cloud cover, and the precipitation one. And it says what's the relationship. Here it says where would you expect to see warm and cold air masses. So these are the air masses. So remember, this is a front. This is a front. So they are out in front of their air mass. So if this is a cold front, it is in front of the cold air mass. If this is a warm front, it is in the front of the warm air mass. Okay, so 1 and 2 ask you some questions. Number 3 says, look at this picture, because for number 3 it says we have this cold air mass that's moving into the warm air mass. So cold air overtakes warm air. And then we have questions that ask questions about number 3 here. Okay, so you guys will have this one to do, these ones to do, and finally this one to do. There's another thing on the back of this where it's just a blown up version of the cold air, the warm air, and what it looks like. Okay. Again, I'll get that 474 through 472 pages uploaded, and that's all you guys should need. Okay, bye. This will be due on, what's today? Wednesday. This will be due Friday.